Yes. Can I get what? I don't have to keep. I lost you at the end. I'm using the trial because I'm cheap. Well, the thing is, Ashni, I would indeed have to pay for it. And then I would have to fill out a form. And then I would have to wait. Screw it. Until I can't do something for free, why would I pay for it? Right? That's just silly talk. If you can do something for free, do it free. That's how I know you guys are a pre-dip class. I only explained that passing out thing once, and it worked perfectly. You would think it's not complicated, and yet. Let's do math. Now, magic pen. There it is. You will notice that on the very front of the page, the top left of the page I just gave you, if you put the holes on the bottom, this chart is there. This chart, I just want to make sure it's the exact same chart because I've screwed this up in the past. It's not quite the exact same chart. There's a couple of extra things on your chart that aren't on this thing. That's cool though. You will notice that I have all of the commonly used measurements in imperial and metric. And I called it metric on this one because in our notes we've been calling it metric. But you'll notice on the official one, it's called SI, which is what it really should be. So it's in your book, so you have it available to you. But it's also on that sheet because as we go further and further away from this in the book, I don't want you to have to flip back to here. All right? Now, what we are going to do is do two things. We are going to work on changing measurements within one system, and then we're going to work on changing measurements between the two. Now, obviously, where we live in the world, changing measurements between the two is the more important skill because we are stuck attached to the United States, and we need to be able to think in both. It just makes life easier, especially if you plan to ever visit the United States and drive somewhere down there. So, but to convert between systems, you use the exact same method as converting within systems. So I start with within systems because you can see how it will work. Now, the problem with that is when you're converting in metric, all you have to do is move a decimal. And all of you are very intelligent young people. You can move the decimal, most of you, in your head. I don't recommend starting that way because then you get a little screwed up when you start working in imperial, which uses no decimals, and working between the two. So I'm going to show you the long way to do it, that always works. And then after you've done it a couple of times, you'll be able to say, oh, I'm just going to move the decimal there. Everyone understand? Okay. The other reason I am showing you this is because of this term right here, proportional reasoning. Proportional reasoning is an incredibly useful skill across your lives. You will use proportional reasoning all the time. And what I'm about to show you is how it works. You will use it in chemistry. You will use it in biology. You will use it in social studies. And that's just in school. You will use it when you are shopping for groceries. You will use it if you have to exchange money from one country's currency to another country's currency. You will use proportional reasoning all the time. So it's a real good thing to have. It just happens to work really well when you're converting measurements. So we use it for measurement. All right? Let us begin then, cabbages. Get it? Thank you, Suhani. Do you actually get it, or do you just know that when I do this, you're supposed to go, ha-ha? Do you actually get it? Okay. Did I? Just making sure. See, now did everybody notice I did not do that joke? When McKenna said you explained it yesterday, and I knew she meant Friday, so I didn't say, yesterday was Sunday. So on Friday of this week, when I say do this work for tomorrow, I expect the same courtesy from all of you. I don't want to hear that joke, tomorrow's Saturday, because I've heard it about 100 bajillion, and I know that's not a number. That's why I chose it, times. Okay? I mean the next day in class. And next Monday, when I say yesterday, I don't need to hear from that same person, yesterday was Sunday. Okay? Okay. Selena.
Are we going to be using Google Classroom in here?
Are we going to be wedding, huh?
Using Google Classroom?
No. No. Because I don't want to bother learning how to do it. The extent of my use of technology is putting the lectures on YouTube for you. Because believe it or not, to do math, you got to do math. And it doesn't matter how much technology I bring to the party. All right, so back to business. Here is how you convert everything always. In math, in chemistry, in biology, in socials, every time you have two values and you need to convert them, you're going to follow this method. If you were in the grocery store and you see a jar of mayonnaise for a certain price and you see another different size jar of mayonnaise for a different price, you are going to use this method to see which jar of mayonnaise is the better jar of mayonnaise to buy for yourself. That is how powerful this is. You can use it every single day of your life if you so choose. Okay? Okay, and here's what you do. You have, I'm going to write it over here. I'm going to write it in, what color do I want to write in today? I'm feeling,
Pink, orange,
okay,
sunset.
pink it is. This is how you take it. You have a value that you wish to convert. It does not matter what that value is. Whatever that value is, that's what you start with. That looks like I've written valve, but it is value. You do not have a valve. You have a value. A value to start. And then you take that value and you multiply it by the following fraction. What you want over what you have. And it makes little sense until you actually write it down. Now, you'll notice that the first one I have to do is centimeters to meters. Now, because you all are aware of how the SI system works, and you know how to move decimals, and you know that meters are smaller than centimeters, so the final value has to be smaller than 485, you have all already converted that in your heads, and I'm talking as long as possible to allow everybody to convert it in their heads, and I haven't taken a breath yet, and I'm getting a little bit dizzy. You all know it is 4.85 meters. You have already done that in your heads. But again, one of the biggest mistakes students make in math is when it's an easy one, they do that in their head and they don't realize what they have actually done. And when the math gets more difficult, they screw it up. Like in algebra, if I say x plus 3 equals 5, you all say it's 2. And I say why? And you say because 2 plus 3 is 5. That's not why. We'll talk about algebra later. So we'll talk about this now. You can all do that in your head. You've already done it. But I want to show you how this works. What is the value I have to start? I have 485 centimeters. So I write that down because that's what I have to start. Then I multiply it, and I'm going to highlight it in yellow to see how I match it up for you because some of you are visual learners. See what I did there? I know. You're welcome. And you have then the value you want. What value do I want to get to? Meters. So I put meters on the numerator, and I will highlight it blue to remind you of what I am doing. Then I have what I have in the denominator. What do I have? I have centimeters. Right? But I have no numbers to multiply yet, do I? Where do I get those numbers to multiply? I get them from my chart. Now, you already know meters and centimeters. That's why I start with SI, because you all already know that one. But you see right here, and I will go in purple, even though it makes it hard to see, 1 meter equals 100 centimeters. So that is where you get your numbers. 1 meter 100 centimeters. Now, when you multiply that, as you all know, because you just did 2 pages of multiplying fractions, what is the denominator officially under the 485? 1. So it's 485 times 1, which gets you 485 over 100. And that math is 485 divided by 100, which of course you know you move the decimal places 2 spaces. Now in SI, you can do that in your head. When you get to SI to imperial, notice those numbers aren't pretty, are they? So we'll be using our calculators there. But here, for the most part, when you are within the same system, most of the time you're going to be able to do it in your head. But not always. Everybody cool? All right. So there it is. It's all nicely color-coded. That is how easy this is at the beginning. Now, 1 second, Suhani. Right now, we're just doing numbers, correct? There's no thought involved. Follow the formula. You've got it. I could train a monkey to do this with enough bananas. Does that mean you know how to do it? No, of course not, because there's knowing how to do something and then there is applying it, right? We all know how to run, correct? Yeah. Every one of you could run. If I let a black bear loose in the classroom, you would all run out of here. Everybody knows how to run. However, does that mean you're ready to go out and run a marathon? But you know how to run. What?
What makes us ready to run away from a black bear?
Well, the fact that you don't want to get eaten. Your parasympathetic nervous system will take over. What I mean is everybody knows how to run, but you don't necessarily know how to apply it to running a marathon. Everybody with me? Sweet. So, do these 6. Something weird happens in number 6. Do them first. Remember, it's want, what you start with, multiply by what you want over what you have. Like I said, a lot of the time you can do it in your head. I want to see what you come up with 1, 2, 3, 4, 5, 6, and then we'll talk about how to fix it if we need to fix it. Go. Where's my button? There's my button. Woo-doo. So, there are 2 things. First of all, we'll talk about, we can talk about the very first one. All of you should have set it up fine, no problem. Hit that up with your calculator. Most of you probably did. 57 divided by 12 with your calculator. Some of you may very well have simplified that fraction to 19 over 4. Some of you may well have simplified that to 19 fourths. But you all should have been able to see that as 4.75. What is wrong with that answer? Because it's the correct answer, but it's not the right answer. AJ. Imperial system doesn't use decimals. So, decimals are breakdowns of whole numbers, right? But in the imperial system, when we break, the numbers don't break down like decimals, do they? What do feet break down into? Inches. So this is 4 feet and then 3/4 of a foot, right? How long is a foot? 12 inches, which we get from our chart. What's 1/4 of a foot? 1/4. 3 inches, right? And I need 3/4. So that is 4 feet, 9 inches. Does everybody understand? Now, I'm going to slide over here and show you something. I had 4.75 feet, right? I know the 4 feet is fine. It's this part that's the problem, right? So I needed to change 0.75 feet to inches, right? So I can just do the conversion again. 0.75 times 12 to get my 9. Everybody cool? All right, so that was the first problem. We fixed it. We know how to deal with it. 3 is easy. What's wrong with 4? I've got another decimal, yes? What do yards break down into? Feet. this is 0.3 of a yard, yeah? Right? Well, it's actually 0.333 of a yard, isn't it? 0.333 is what fraction? 1/3. What is 1/3 of a yard? 1 foot. So what should this really be? 45 yards, 1 foot. Not a decimal. Everybody cool? Okay, 5's easy. Now 6 is a mess, right? Why did I give you this here? Because are they supposed to be decimals? No. But miles don't break down into something pretty, do they? Look on your chart. Miles break down into 1,706 yards, 5,280 feet. They're giant numbers, yes? So by agreement, when we're dealing with miles, we often leave the decimal. Is everybody cool with that? It's one of those things. You can't learn a hard and fast rule because sometimes the rules don't make sense, right? If I was saying I was going, to drive somewhere that was not quite a whole mile, I wouldn't say I'm driving 7 miles, 3,285 feet, would I? I'd say I'm driving about 4 3/4 miles. Everybody cool? Okay. So, do 7, 8, 9, 10. On page 17. Just 7, 8, 9, 10. Should take about 5 seconds. What do you find when you get to 10? If you're not at 10, just wait till you get there. Why is 10 problematic? There's no comparison for centimeters to kilometers, is there? Because that's an idiotic thing to convert, right? Right? Like you would never say, I'm running a 10-kilometer run. You would never measure that in millimeters, would you? I'm running 100 million millimeters. You wouldn't do it. This is a math problem, right? This is a math class question. I hate them. I like to give you problems that might possibly ever hit you up in real life. This is not one of them. But why is it there? To show you that you can work it out even if you don't have the exact conversion you need. Because what do you have? You do have 17.2 millimeters to what's on your chart? You have meters or millimeters to centimeters, don't you? And then you can go centimeters to meters and meters to kilometers. You could do it 4 times. You don't need to, though, because you know how many places you're moving that decimal, right? But in case you don't, you might go centimeters, 1 to 10 millimeters to get 1.72 centimeters. And then you know, I got to divide by 100 now to get the meters. Divide by 100, and you're going to get 0.0172. Then you got to multiply by another what? Where am I now? I'm at meters. How do I get to kilometers? Divide by 1,000, which means that decimal place has to move how many spots? 3. And what goes in the holes? Zeros. 0.1234117. I'm out of room. 2. Now the reason this works is because in SI, it's always the same. So even though we did not have kilometers to millimeters, we can figure it out going through the steps that we do have. Is everybody good? Sweet. I didn't want that to happen. Now, we have some actual real life type of questions that may occur to you. They're all pretty easy, but you will notice that there's words involved now, yes? So you have to actually look at what is being asked. First 2, no problem at all. The first little trick happens in the third one. So the first one, we have 6 feet 4 inches. How long is this plank? Do I care in the original? Do I care about the feet or the inches? I've already got the 4 inches. Do I have to do anything with it? So I only care about what? The feet. So I got to go 6 feet and I want inches. So it's 12 over 1, right? Because 12 inches is 1 foot. Now, hopefully you're all already getting to the point where you're realizing that you don't need to care about the units. And what do you do with the 1? Do we care about the 1? We always get rid of it. So since the 12 is there, we know this is 6 times 12, which we know our 12 times table is 72. But here is where you're going to make your mistake, and that's the reason I'm giving you questions this easy early on. How many of you are going to forget about that 4? Hopefully none, but some of you will, because I've marked the quizzes on this for 20 years. And if I give a multiple choice quiz and say A is 72, half of the class is going to circle A. Because their calculator, because most of them aren't going to do 6 times 12 in their head, they're going to see 72 on their calculator, they're going to see it on the paper, and they're going to circle it. When what is the real answer? Plus 4 to be 76, which is always choice D. Everybody understand? I don't like to pull that crap on you people, but you have all written multiple choice math tests where your teachers have done that to you, haven't you? Right? I try to avoid it. The reason teachers do that to you is because when you give a multiple choice test, the answer is on the paper, isn't it? Right? You can always work backwards from the answers. That's why we have to mess with your heads and do things like that. That's also why I don't like using multiple choice. Because multiple choice does not necessarily show me how you can do math. It shows me you know how to take a test. And this is not take a test 10, is it? This is math 10. Everybody with me? Now, I always throw some multiple choice in there to make sure that everybody has a good base from it. All right. 12 is easy. What is it? 204 inches, because you had to do yards to inches, and then feet to inches, or you could have remembered just in your head that 5 yards equals 15 feet, right? And then you know that, and you could have just done 17 feet to inches, right? Now, the question needs to be asked now. Do I care how you solve a question like 12? Will I ever care how you solve a question like 12? No. Would I ever on a test give you a question as easy as 12? Probably not, because, Toya, you can do that in your head without showing me any work, can't you? And if you do that in your head, are you going to remember to show me work? Some of you aren't. And am I able to believe you if you just write that on the piece of paper? I really can't, can I? Because I am not the type of fellow who goes and gets dividers for every quiz. Right? Everybody understand? So even when it's something like that you can do in your head, show me something. Okay? Now, number 13 is a bit of a trick. So let's check it out. What do I got? What do I got to convert? I got to convert yards into feet and then inches. I can go straight because I know that 36 inches is 1 yard, right? So I can go 6 yards times, I want inches, 36 over 1. 6 times 36 is what? 216. Now, what do I got to do with that 216? What am I doing, Selena? I'm dividing it by 5. Now, when you do that, how many of you are going to go to your calculator for that? Be honest. Everybody, right? So when you do that, what happens on your calculator? 216, curses, 216 divided by 5. 43.2. Everyone agree? How many banners can I make? 43. Everybody understand? That's 43.2 is not the right answer. Now, here's what I like to do. What if, and I'm stressing what if, I have 218 inches of fabric. What would I divide it by? I'd still divide it by 5, and I would get 43.6. How many banners can I make? 43. Still 43. Why? 43 is the whole number. I cannot get another banner out of that. In a math class, what is that answer? What would you say? 44, because we'd round up. In real life, we can't make that banner appear. Does everybody understand? Cool. I'm going to highlight it because all of you said you understood. That's a little bit of a hint, right? Good. Now, what can you do with 14, 15, and 16? What is your choice there? You have a choice. What can you do? Manraj. Do I care which one you do? Nope. So if you're going to leave it as kilometers, which I'll do in red, it's going to be 2 minus what? 0.755. And that's going to get me a kilometer answer. What if I want it as meters? What's it going to be? 2,000 minus 755. Are they both equally right? Yes. Do I care what you do? No. And you will give me an answer of 1,245 meters or 1.245 kilometers. Yes? Excellent. Should have been blue. What's going to happen with 15? I've got 3 things to add up. Which one of those should I not touch? I should not touch the kilometers, should I? So what do I got to do with 125? But I want my answer in kilometers. So what do I got to do with the meters? How? Divide it by 1,000. Now, question again being, automatically you want to multiply. A bunch of you said multiply. You got to stop and think. If you multiply that by 1,000, you're going to get 125,000 meters, aren't you? Kilometers. Is a kilometer bigger or smaller than a meter? Bigger. So the decimal must be smaller, right? So we keep the 1.35, but we're adding 0.125. Now, what about centimeters? 0.040 to go centimeters to kilometers. How many decimal places do I need to go centimeters to meters? You're giving me away. Centimeters to meters. 2, and then meters to kilometers. 3 for a total of 5. Where does the decimal really live in 40? After the 0, and it's got to move 5 spots, right? So 1, 2, what goes in the holes? 3, 4, 5. So I need 3 zeros. 0, 1, 2, 3, 4. Do I need that 4th zero? Of course not. And then I would add that up. 1.475 right? Now, which one do I not care about in 16? I want to answer in yards, so which one do I not care about? I don't care about the yards. I know I'm starting with 12. How do I convert miles to yards? 4 miles times, what's my fraction? 60 yards, what I want, over what I have, 1 mile. So that's going to get me whatever that is. I can't do that in my head. Maybe I can. 6,800, and 4 times 60 is 240. 7,040, right? 7,040 yards. Plus 12, 752 yards. Now, what about 13 inches? Can I use a decimal? Technically. So I can't use a decimal here. I need an answer in yards, so it's 13 inches out of how many to make up a whole yard? 36. That's the best possible answer. Is 13 close to 12 inches? So could I say 7,052 yards and 1 foot? Do you think I would be okay with that if you showed me that as your answer? Take a guess. You've known me for 4 days. Sure I would. That shows me you understand measurement, right? And let's be honest. If I'm 1 inch off in a calculation that is 4 miles long, is that going to make a difference? No. Everybody cool? All right. 17 and 18, everybody does wrong. You guys try them. Talk to your neighbor. Everybody gets half. Huh?
Never mind.
Beautiful. You would all put that over your fireplace. What's funny is if a 5-year-old drew that and his parents put it on YouTube, it would go viral and somebody would pay $150,000 for it and the kid would never have to pay for anything in their life again. But I draw it here and all of you are like, I'd throw it in the fireplace. Anyways, it's already posted on YouTube. Now, the other thing, of course, is all of you would be like, you can't draw, Mr. Myers, but if we were playing Pictionary and I drew that, you'd all go, sailboat, which means I can draw. So, anyways, if this is 5 feet and this is 3 feet, but the frame is 1 inch thick, how much framing do I have to buy? We know that this is 60 inches, and we know that this is 36 inches, right? The picture. So what do I need to do to make the frame 1 inch thick? Sean? 1 inch for each side. So this side up here would be 61 inches. And this side, oh wait, I'm going to change color. This side would be 61 inches, and this side would be 37 inches. Everyone agree? Yeah. Okay, so that would mean that my frame would look like this. One moment, let me get brown. 1 inch all around. So I need to add an inch where? To all the sides. So this is, you said add an inch. All the sides. Well, I did that. I made this 60 to 61 and this to 37. There you go. What do I need? 62 and 38. Right? Which is 100 and then another 100. So what do I need? 200 inches. All of you feel free to take a picture of that so you can enlarge it and put it up on your fireplace. All right. Next question. This question came off a provincial exam. Now, you don't have provincial exams anymore, but this question was on a provincial exam. It didn't say my living room. What is wrong with that question?
There's no period.
I see. It's going to be like that, is it? There we go. There's obviously a dot below it. It's a question mark. Okay. It's going to be like that, is it? Better? Wait a minute. Let's pretend we're in Spain. There. All right. Enough wise ass. Okay. Somebody already said it. Somebody already said one of the problems that's wrong with this question. What was it? What is a linear foot? If you don't know that, yes. Hi, Yuting.
I'm just wondering if I could grab Benito the Dodge for the leadership Oxford cancer event that's happening today at lunch.
Wasn't it happening on Thursday? But yes, whatever. Go. See? Third day of class. Remember how on the first day I said classes get messed up with blah, 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 blah. Well, you go, girl. So, if you don't know what a linear foot is, you're in trouble, yes? Okay. What else is wrong with that question? Selena. Okay. Does anybody else see a problem with that question? McKenna. Okay. Still, it comes back to that word linear foot, right? We don't know what it means. Yeah? Preston. Yeah. What's a crown molding? Who knows? 2 out of 30? 3? As time carries on and more people watch those shows on HDTV about rebuilding a house, more and more people, when I first started asking this question, nobody put their hand up. And now that everybody watches, Beachfront Bargain Hunt, the renovation edition, everybody is starting to know what these things are. What is crown molding? A lot of you will have it in your homes. Manraj, what is it?
Basically baseboards for your roof.
Baseboards for your roof. What's wrong with defining them that way? People don't know what a baseboard is, right? And that's what I'm saying. This was a question that was going to be on your provincial exam. This was going to make up 1/60th of this year's kids' grades. And before they can even do the math, there's 2 problems with it that have nothing to do with math, right? So one of the things we've been trying to do as math teachers is get rid of questions like this. I like putting them in there because in the real world, does anyone get rid of these questions? No, these are the questions you got to learn. So first thing, let's talk about crown molding. We already did. Crown molding goes around the walls, between the wall and the ceiling. It's just for looks. It serves no purpose except looks. Same with baseboards. Well, the reason they are there is because painting is difficult in corners. So if you paint almost to the floor, you can cover up the fact that you didn't paint all the way to the floor with the baseboard. Same thing with the ceiling. How many of you look closely at the corners of the rooms at your home? If you look carefully and you don't have crown molding, you will see splotches of white on the wall from when they painted the ceiling. Or you will see splotches of whatever color your wall is on the ceiling from where somebody missed a spot. Unless they use tape. I know this because I have painted many rooms in places I've rented, so I don't care, and I don't bother with tape. I just get close. And the people who painted my house before I bought it did a crappy-ass job. And I've been living there for 10 years. I've been too lazy to fix it. AJ, hit me.
What if the wall and the roof are the same color?
Trouble. That's a smart move. Then you can just paint. Then you could just like throw a bomb of paint in your room like this. Paint. Room done. Okay. So we fixed that up. We've discussed it. Now, we've covered crown molding. Linear foot. What word do you see in linear? Yeah. I love it. Somebody always says ear. It makes me so happy. What math word do you see in linear? Line. What's a straight line? From one point to another. That is a linear measurement. Does it matter if I make it that thick? No, it's still a linear measurement. A linear measurement is a straight line. We use linear measurement all the time, right? How tall are you? I'm 5'7.5". That's a linear measurement because it goes straight from the floor to the top of my head. Straight line, right? So, the living room is a rectangle that's 185 by 240. So if I want to put crown molding around the whole ceiling, what do I have to do with both those numbers? My room is 185 by 240. I should convert it to feet, shouldn't I? Because the crown molding is sold by the foot, right? So I'm going to convert that to feet, correct? That's going to give me two numbers. What do I need to do with those two numbers? Divide. First thing. Yeah, first we got to do our division. I'm with you now. Okay, I understand what you're saying. So you got to do 185 divided by 12 and 240 divided by 12, right? What's that going to give you? It's going to give you a decimal. Do we care yet? Not yet. 15.416 and 20, right? What do I need to do with those two numbers? Selena, I need to double them. Why? A lot of living rooms have 4 walls. I mean, unless your living room is on TV, then it's only got 3 walls so people can watch you. Unless you're Deadpool, and then he breaks the 4th wall all the time anyway and talks to you. But that's neither here nor there. So I've got to double them, yeah? So I got to do that to get what? 70.83, right? Feet, yeah? Now, if the crown molding is sold by the foot, does that 0.83 matter? What do I round it to? 71, because I need 71 feet to cover it all, don't I? Now, if I was really doing this job, would I go to Home Depot and say, I need 71 feet? What would I really do? I'd get some extra, because chances are someone's going to screw up one of those cuts, aren't they? If any of you have done any work, you know that. Or the house is not quite perfect anymore, and it's not square, and all kinds of problems. So you know you need 71. Then what do you need to do with that number? $379 to get a whole answer. And you get 269, 269.09. Now, is everybody with me? Please notice how easy the math is on these questions. We divided, we added, we multiplied. Is the math difficult? No. Where is the difficulty? Setting it up. Everybody with me? So even though you're all very good at this part, divide by 12, add it up, multiply by 2, 9 times 3.79, no problem. Do not rest on your laurels that you're ready to go. Everybody understand? Okay. I don't remember how long class goes today because it's a new day. Your job, 4 minutes? Great. Your job is page 19, 20, and 21. Yeah, but I don't really care, right? Your 19 is easy to get done, and if you look closely at 20 and 21, all of page 20 is one calculation with your calculator, right? It's really just one page. If you actually work on it, it won't take very long. Yep. Pages 19 to 21.